Hello, this is Jim, and we're gonna solve a Tower of Hanoi problem. Tower of Hanoi problem is you have three pegs, and in one of the peg, you have rings from smallest to the largest, from from top to bottom. We'll call it tower, and you have to move this tower by moving the ring from the top and entirely to a different peg. So we'll call each peg A, peg B, peg C. And if a tower is at A, we're gonna move the entire tower to either B or C. It just has to be in either of the peg. But you have to move them all in the same order. So if you have the tower on A, you're gonna move the tower exactly the same order to either B or C. And when you move the tower, you cannot do everything all at once. You have to move each ring to a peg. So the rule is you can only move one ring at a time. And the second thing is you cannot place smaller ring. You cannot put a larger ring on top of a smaller ring. So by illustration, you cannot have larger ring on top of smaller ring. This is not allowed. No reverse order. Okay? So to move the tab, let's think about it. If you don't have any ring, then you don't have to move anything. So there are 0 steps to take. And if you have a 1 ring, then there's 1 step to take because you just have to move that 1 ring at some peg to another peg. And if you have a two rings, now it's a bit complicated. Not too complicated. But if I can give you an illustration here, you have to move the smaller ring to peg B, and once you place the ring to the peg B, cannot place the larger ring on peg B, but have to place it on peg C. And you have to put that smaller ring you placed at peg B on top of this larger ring, which is on peg C. So let's count. Step 1, step 2, step 3. So it took 3 steps. Now let's move on to the with 3 rings. This time, let's imagine how it should work. So with top 2 rings, we know how to move it to different peg. Say peg B. Once we move that to peg B, we know how many steps it just took. So 3 steps. And to move that peg, a larger peg, to leaving a room for a larger peg to be on peg C, right? So now that the largest ring is on peg C, we can move that two smaller rings back onto the peg C, which the largest ring is at. So another 3 steps. That's total 3 steps to move two smaller rings onto pack B, and one step to move largest ring onto pack C. Now finally the remaining top two rings on tower pack B onto pack C should take about the same as it is a two rings to another peg, so 7 steps in total, right? So here's the idea. If you have if you want to know how many steps it'll take for a number of rings, say n rings, and we're gonna call it Tn, then it should take at most Tn minus steps to move that smaller n minus one smaller rings onto another peg, and move the largest ring onto another ring, and to move that n smaller rings back onto the largest ring. So should take about 2Tn minus 1 plus 1 steps. Can we do any better? No, it turns out it's not just a feast, it's a necessity, because for the largest ring has to be another peg, and to move that largest ring to single peg, we need to move n minus 1 smaller rings on a single peg. So it should take at least Tn minus 1 steps to move to single peg, and the largest ring now has to be on the empty peg where there aren't any rings. 1 step required minimum, and another Tn minus 1 step has to be taken to be placed on the top of the largest ring. So that's total T 2n minus 1 plus 1 is our minimum. So proving the fact that it has to be equal to 2Tn minus 1 plus 1. So this is our recursive solution to Hanoi problem. The number of steps to take n rings takes 2 times of smallest rings movement plus 1 step to 1 step as you need to move that largest ring to another peg.